Good morning, on all present here. I'm Nandini D, working as an assistant professor in SNS College of Engineering at the Department of Computer Science and Technology. Today, we are going to see a topic related to relational algebra. Let us see first what is a relational algebra. What we can say relational algebra means a relational a relational algebra or relational query language is a language used to interact with relational databases to retrieve, manipulate, and manage data stores in tablets. Let us see what is uh, retrieve. We can easily retrieve the data. We can easily manipulate the data and manage the stored data in the tables. For this, we can say that relational model supports simple or powerful query languages. First one for that will be it consists of a strong formal foundation based on logics, allows for much optimization. It is used for much optimization. Query languages, which is used for programming languages, QLs not expected to be turning complete. It also uses a complete calculations which supports easy, efficient access to larger data sets. Therefore, there are two formal relational query languages. It consists of two mathematical query languages from the basics for real languages and for implementation. It consists of relational algebra. Another one will be in relational calculus. What is a relational algebra? It is used for more operational, very useful for representing execution plans. And the relational calculus, it's used for let us user describes what they want rather than how to complete it. These are the two examples of formal related query languages. What is a relational algebra? And there are some basic operations in the first one. Let us see a selection operator which selects a subset of rows for relations. Next one will be a projection operator which is used to delete the unwanted column from the relation. Cross product operator allows us to do some cross operations. Set our differences used to do for tuple in the relation but not in the relation. For union, it tuples in the relation, one in relation. Additional operations such as intersection, joint, division, renaming, not essential. These are some of the algebra. For example, first when we are going for a selection in algebra. What may be a selection in algebra means? So the selection in operation is usually denoted by the lowercase Greek letter notations. So this selection in operation is an urinary operator that denotes a subset of a relation. What will be a subset of a relation means? For querying the languages, we use this subset of a relation 1. Next one, for that notation, sigma of condition, relation of. For example, sigma age is less than 25. This query selects all the rows from the student relation where the age is greater than 25. Where the age is greater than 25. Next one is a projection operation, is represented by the Greek letter pi. For notation, we use what will be a projection operator and what is the use of that projection operator. This projection operator consists of pi less than attribute to list then of relation. This projection is a linear algebra. It consists of projecting a vector onto a subspaces. Then projection operator in quantum mechanisms are used in physics. Sometimes it is used for PowerPoint slide projections. Like these ways in the relational operator, this projection operation is used. Example, pi of name comma age of student. This relatives only the name and age column from the student relation, removing all other like student ID, addresses, etc. Next one is that cross product in relational algebra. So this cross product is usually denoted by the symbol into, because we are taking two different tables. That two different tables are joined by a relation into. So it is also known as Cartesian product. This cross product combines every tuple in relations R with every tuple in the relation S. This results in a new relation with different attribute of both R and S, and the number of resulting tuple is R into S is equal to a modulus of R into modulus of S. For example, we can see that in notation relation A student ID and name has been represented. In relation B course ID and course name has been represented. And the common thing, we are going to take a cross Cartesian product for these two. So what will happen? Student into course. So student ID, his name, course ID and his course name all gets Cartesian product at the time. This is very often used as a basic form of joins to naturally join these two cross products, can result in larger amount in not filtrations. Next one is a set differences. What is a set difference? The set different operator tuples that are in one relation but not in another. For example, how we can say the set difference operation returns all the tuples that are in one relation but not in another relation. That means it can be represented by R minus of S. This describes a result contains tuples that are not R but not in S. So R and S must be union complication, meaning that they have the same number of attributes which correspond to the attribute have the same domains. For example, we are seeing here is relation 1 minus relation 2. So relation A is student A, relation B is student B. In the relation A, student ID with 1, 2, 3, name with Alice, Bob and Carl. Student B with student B, student ID with 2, 3, Bob, Coral, name. So what will be the set differences for the student A and student B? What is known as a set difference means the student A and student B, the common gets eliminated and the which one is in a different form that is being executed. This is the set difference. Thank you so much for the video.